everyone, welcome to InfoStream YouTube channel. So in this video, let's discuss the second problem related to the Turing machines. So that is a power n, b power n, c power n. For the given language, if we want to design the string, that is the possible string. So the n value must be greater than or equal to 1. It may be 1, 2, 3, anything greater than or equal to 1. So first, for the first condition, let's consider it as 1. So if n value is equal to 1, a power 1, b power 1, c power 1. So a 1 time, b 1 time, c 1 time. Next, if it is 2, a power 2, b power 2, c power 2, a 2 times, b 2 times, c 2 times. If it is a power 3, b power 3, c power 3. So a 3 times, b 3 times, c 3 times. Like this only it will continue. Now, among the possible strings which we generated, which string we must use to design the Turing machines for the specified problem means, here how many number of variables are there? 1, 2, 3, A, B, C. So 3 variables. So what we will be using? N value as 3. That is A power 3, B power 3, C power 3. Which is the string? This one. A power 3, B power 3, C power 3 will be used to design the Turing machines for the given problem. So now we selected a power 3, that is a 3 times, b 3 times and c 3 times. So if we consider this as the string, this here, the string which we selected now will be the part of the infinite string. So it will be having the blank spaces before its start and it will be having the blank spaces after its execution or after its over. So this string will be having the blank spaces before also and after the string also. So from A we must start. We must only consider the blank spaces which are after the string which we selected. Now how Turing machines work means, this read-write head, this arrow mark will be called as the read-write head. This read-write head can move from right to left, left to right, or as the capacity to change the value. That is, it will rename it. Now if I encounter A for the first time, I will rename it as X. Next, after A, I can only replace B. I will replace it as Y. Next, I must move to C and I will replace it as Z. Again, I must come to X. I must come to X because A is replaced as X, and then I will move to A and I will replace it as X. Then I will again move to B, then I will replace it as Y. That is, after one A, you can only replace another B. Next, C. All one time over means next you will be coming for the another cycle. That is, A 2 times, B 2 times, C 2 times. After that, again you will come to A, B, C, A, B, C, A, B, C. Like this only the cycle will be continuing. So let's start from A and let's design the transition states also. So if we start from the A, that is the first element in the string that we selected, I will take it as Q0 state, which is the initial state. From Q0, I will be moving to Q1. You can use any variable to denote the states you are using. So now I am moving from Q0 to Q1. When I encounter A, I will replace it as X and I will move to right side. When I encounter A, I will replace it as X and I will move to right side. Now my read rate it came to the right side, that is A. After replacing one A, I can't replace the A which is beside it, because after one A I must replace one B, next one C. Again I must come to A, B, C, A, B, C. Like this cycle must happen. So what I will be doing, I will be keeping it as it is. That is, if I encounter A, I will write A as it is and move towards right side. Next, I move towards right side, I again encountered A. If A is there, A will be remaining as it is and I will move towards right side. Now I encountered B. So what I will be doing, I will be moving to the next state, I will call it as Q2. When I encounter B, I will replace it using Y and move towards the right side, because I still want to move towards the C. So I will replace it as Y. I can't replace the next B. So here the command said that move towards the right side, but I can't replace B using Y, because after 1A, 1B, 1C, the cycle must be like that itself. So what I will be doing, I will be giving the self loop. If I encounter B again, I will write B as it is and move towards the right side until I get C. Next, right side. If I encounter B, I will write it as it is and move towards right side. Now I encountered C. So what I will be doing, I will be moving to the next state. I will be calling it as Q3. If I encounter C, I will replace it using Z and move towards the left side. So, YA came to the left side means 1A is over, 1B is over, 1C is over. Again I must come to A. If I want to come to A, I must move left side. So I can't directly come like this, I must be coming one step back side. Now, I again encounter B. Whether I have the chance to change B name as Y again? No. I must come to X, then I must change A, after A, B, after B, C. Again come back to A, like that. So if B is there, what I will be doing? I will be writing B as it is and move towards left side. Again B is there means write B as it is left side. Now I encountered Y. So you will keep Y as it is. If I encounter Y, write Y as it is, move towards left side. Next, I again encountered A. So if A is there, write A as it is, move towards left side. Until you get X. So A is there, I will write A as it is and move towards left. Now I encountered X. So when you encounter X, come to the initial state. When you encounter X, write X as it is and move towards the right side. When X you encounter, move towards the right side. Now if you move towards the right side, you came to A. So if you see here, from Q0 you are moving to Q1. If A is there, replace it as X and move towards the right side. Now you again encountered A. So if A is there, write A as it is and move towards the right side. Now B has been replaced using Y. When I moved to the right side, I encountered B. So whether I can change this value? No, because I can only change the B value. So if you encounter Y, write Y as it is and move towards right side. Now I came to B. So 1A over, 1B over, 1C over. Again came back. 1A over again. So 2A are over. Now I can replace B value as Y. So when you encounter B, write it as Y and move towards the right side. Again I encountered B. If B is there, write B as it is and move towards the right side until you approach C. Now you encountered Z. So if you encounter Z, what you will be doing? If you encounter Z, write Z as it is and move towards the right side. So again, when the read write it move towards the right side, now you encountered C, the second C. 2A over, 2B over. Now I can replace C using Z. Replace C using Z and move towards the left side. Because 2C is over, now I must come back to X again and I must move to A, B, C. Now, what it said, move towards the left side. So I approached Z. So when Z will come, write Z as it is and move towards the left side. So again if I come to the left side, I approached B. So B is there means write B as it is, move towards left. Next Y. If Y is there, write Y as it is and move towards left. If Y is there, write Y as it is, move towards left. If A is there, write A as it is, move towards left. Now I encountered X. So you must come to X, then only you can move to A. Now you came to X, write X as it is and move towards the right side. Now you encountered the third A. So replace A as X and move towards right side. So if you move towards right side, now you encountered Y. Write Y as it is and move towards right side until you approach the third B. So now again Y was approached. So write Y as it is and move towards right side. Next B. So if you approach B, write it as Y and move towards the right side. So this is the third Y. Next Z is there. If you approach Z, write Z as it is and move towards right. Next, if you approach Z, write Z as it is and move towards right. Now you approach C. If C is there, write it as Z, that is replace it as Z and move towards the left side. So if you move towards the left side, again you encounter Z. Write Z as it is, move towards left. Write Z as it is, move towards left. Next Y, write Y and move towards left again. Write Y, move towards left again. Y, move towards left again. X, so if you encounter X, write it as X and move towards right. So now when we came to the initial state, after all we came to the initial state. Now you must come to the initial state. So only I came back to X and then I went to Y. When all the elements were traversed also, I came from Z towards the X and came to Y, because I must come to the initial state to represent the blank spaces after the string. We don't consider the blank spaces behind the string, we will only consider the blank spaces after the string. So all the elements inside the string are already replaced using X, Y and Z. Now we want to represent the blank spaces in Turing machines. So what I will be doing, I will be taking the another state, that is Q4. Now we are at here. So what I can write, when you approach Y, write Y as it is and move towards right. Now you came to here, again Y is there, so I will give the self loop. How many number of Y may come? Write it as Y and move towards the right until you get the Z. Now I got Z. So what I will be doing, I will be moving to the next state. I will call it as Q5. So if you encounter Z, write Z as it is and move towards the right side. Now again I encountered Z. So I will give the self loop. Write Z as it is and move towards the right side until you approach the blank spaces. Now I approach the blank spaces. So Q6, this will be the final state because we encountered the blank space. If blank space is there, write blank space as it is and move towards the right side. Now if infinite number of blank spaces is there, means I will give the self loop for the final state. How many number of blank spaces may come? Write it as blank space and move towards the right side. Now the problem is over. If you want to write the transition state, I will show some of the transition state how you want to write. So you can write all of them. So if you see here, first transition state, that is from the starting, from Q0 I went to Q1. From Q0, of Q0 I went to Q1. So when I gave A as the input for Q0, it replaced it as X and moved towards right side. Next, Q1. Self loop are there. Two transitions you can write. Of Q1, self loop means it came to Q1 itself. So you can write it as, when I give Y as the input, it wrote Y and moved towards the right side. Next, of Q1, that is self loop itself, Q1. When I give A as the input, it wrote it as A itself and moved towards the right side. Next, here. From Q1 to Q2, next one, of Q1 comma, when I give B as the input, it went to Q2 state by replacing B as Y and moved towards the right side. So like this you can write for all these states. So hope you understood how to design the Turing machines. So this is the second problem. So first problem link will be given in description, you can see it there. And if you solve many problem related to this one, which I gave in the playlist, you will be ready enough to solve any problem in the examination. So if you liked the video, don't forget to subscribe and like the video. Thank you.